Hello everyone, welcome back to my channel. Today let's go over a Leetcode hard question that I just solved on my own. So I'm really proud of this, and I'm really glad that I was able to come up with my own solution to this question without any help. So let me show you how I did it. This one's called Unique Paths 3, and basically what you want to do is you have this grid that you're given and you want to start from ones and get the twos. You can't walk over the negative ones, and you want to return the number of walkways, so all in four directions, that go from the starting to the ending square, and walk over every non-obstacle square exactly once. So let's go ahead and take care of this requirement first. So let's go ahead and move through our grid, and let's go ahead and say if grid I of j is not equal to -1, then it's a non-obstacle one, so we want to walk over those exactly once. So we can go ahead and include them in a key. And let's print self.key. So the goal is to just hit this exactly once. Okay, so now let's go ahead and do a DFS. And it says here we can only begin with ones, so if grid ij is equal to 1, then we can kick off the DFS. Okay, so now we can just basically use a list called cur, do our boundary checks. Or this is equal to -1, then we can't go. Otherwise, let's go ahead and mark this one as visited. Well, first let's traverse all four directions. And obviously we have to pen the current cell. So also we don't want this to be visited, so let's call this original is equal to grid ij, and then we have to mark it equal to v so we don't come back to it. And then after backtracking to the original start point, we have to reset this back to original. And let's go ahead and print cur. Okay, output limit exceeded. So if grid ij is equal to 2, then that we're at the ending point, right? So then we can do this and we can just return. Okay, or grid ij is equal to v. Okay, cool. So now we're just looking for the paths that are equal. Looks like we have a lot of them. So we don't want duplicates at all. So we can say if sorted self.cur is equal to sorted self.key. Oh, just cur. Okay, that's not right. So exactly non-obstacle once. So let's go ahead and do that here instead. Okay, cool. So you can see these two are lining up, and then we also have to say cur.append ij because the ending cell also counts. And then if sorted cur is equal to sorted self.key, then we can print it. But why is that not showing up? Have to walk over exactly once. So if length of cur then we can print this. That is weird. So we basically have our solution. It's right here. So 1, 2, 3, 4. You can see those are the longest ones. And then we have to just make sure that they line up, which it looks like they do, except the ending cell is not in there. So let's also create a dictionary. So let's call this now. Cur now of C. Tuple of C plus equal to 1. And then we have to do the current ending cell. If now is equal to self.dk, then print cur. Okay, cool. So yep, that's what we need. So we just compare them after we do the comparison, and then because this is going to be exactly once, we don't duplicate cells in this. And then yeah, so basically now you just have to count how many of those there are. So self.answer plus equal to 1, and then at the end, after you run the DFS from that one starting cell, just return the self.answer. Okay, so let's run this, submit it. And there you go, passes all test cases. So again, I'm really glad that I was able to come up with my own solution to this question without any help and solve it on my own. So that's it for this video. Thank you for watching and stay tuned for more.